Hi, this video explains the different storage classes in C. Storage classes in C defines the scope or visibility, lifetime, memory location of the variables. Scope and visibility means the area in which that variable is available or visible. Second one is lifetime, that is how much time it is accessible in the program. Then memory location of the variable, the actual location of the memory where the variable is stored. The four classification of the storage classes are automatic, external, static and register. Below it is written the keywords used for all these. Automatic is auto, external used for external, static for static and register for register storage class. We shall see all these in detail. Automatic storage class. By default, all local variables are of this type. The scope of automatic variable is automatic storage class is within the block or it is local to where it is declared. The keyword used is auto, and actually there is no need to write the auto keyword. For example, auto int I is same as writing int I. That means there is no need in writing the keyword auto. By default it will be automatic type. The memory allocated automatically and it is deleted on exiting the block. Lifetime is within the block only. An example showing the automatic data type, automatic storage class. You can see there are a main function, a for loop within the function, a while loop within the function, a block of data within brackets, and an external function, an extra function that is fn. So in the main function there are two variables p equal to 9 and k that are int type, and the auto keyword is used. Actually, if we use the auto keyword, there is no much difference. That is, like, we can write it like int p is equal to 9 comma k. There is no difference in writing the keyword auto or not. Then the next variable is int I is equal to 4. So I is available only within this function. I is available only within the main function. P and K are also available only within the main function because it is declared within these two braces. Okay, so this determines the boundary of availability of the automatic variable. So P, K and I are available only within these two blocks. So these will be available in the blocks inner to these two braces. That means this will be available in the while loop, this will be available in the for loop, this will be available in the block that is declared here. Now we shall see the functionality. While I less than 4, printf I is equal to %d only available in main I++. So it will print the value of the current value of I. So in the first case, now I is equal to 1. The condition is I less than 4. So when I++ is executed, the current value 1 will be printed. That is, I is equal to 1 only available in main function. Now it is calling the function fn. Now it is calling the function fn and the control will go to the function fn. There another automatic variable is defined, int j is equal to 0. Here this j will be available only within these two braces. That means it will be available only within this function. So it is printing j is equal to %d only available in fn. That is, it is printing the value of j equal to 0. So this is shown here. J is equal to 0 only available in fn. Then it will come back to the program. Again it will check the value of I, and as it is less than, as it is incremented to 2, now the value is 2. In this step it is actually incremented to 2. So 2 is less than 4, so it will print the value 2 here. As this is a post incrementer, the current value only will be printed. So after executing this instruction, the value of I will be incremented to 3. So now 2 will be printed. That is, I is equal to only available in the main function. So in this way the operation will be ended till this condition is satisfied. That is, it will execute up to this portion. This loop will continue up to this portion and it will exit the loop. Now inside this for, another variable int k is equal to 0 is defined. Int k is equal to 0 is defined. That is actually available only within these two braces. The variable k will be available only within these two braces. Actually this k is, the location of this k is different from this k. That means these two k's are having different memory location. As I am initializing the value, defining the value of k is equal to 0 here, this k and this k will have different memory locations allocated, and the value of this k will be available only within these two braces. So it is printing the value. This is for just printing the value from 0 to 1, that is 0 and 1. K less than 2 condition is given, so it will print k is equal to 0 and 1. So that is written here. K is equal to 0 and k is equal to 1. These two values are written and it exits the loop. Now int p is defined. Int p is equal to 5 is defined inside these two braces. That means it will be available only within these two braces. It will not be available outside the program. The meaning is that this p is different from this p. These two p's are allocated different memory locations. Now it is printing the value of p from this block, that is p is equal to 5 will be printed. So you can see here p is equal to 5 only available in this block. Okay, so it is coming out of this block. Now it is printing p is equal to %d. At this stage it will print only the p which is available throughout this block. The p which is available throughout this block, which is this p. The value of p is now equal to 9. So this will print the value equal to 9. That means p is equal to 5 is deleted within this function itself. As soon as, not function, this block, as soon as this block is exited, the value of 5 will the value of p will vanish. So this variable will not exist. So now p is equal to 9 will be printed. Instead of this %d, it will print p is equal to 9 because the scope of p is equal to 5 ended in the previous block. Okay, this is all about automatic type. Now we'll see external type. All global variables can be made available in other files using this type. To make a variable of our file make available in another file, we use the external storage class. The scope of storage class is global. The keyword is extern. Memory allocated when this is defined. For example, extern int a will only declare the variable, but int a will define the variable. Extern int a will only declare, but int a will define. So memory is allocated only when this is declared. This is defined. The lifetime is till the end of the program. An example of usage of external. Here I have made two files, file1.c and file2.c. This is file1.c. This is file2.c. The file 1, the main function exists. The main function is within file 1. So in the main function I have a variable which is globally declared int I, and the value is defined here, I is equal to 9, and I have just called a function fn. So when the function is called, it will check for the definition. So to check for the definition, it will come here, extern void function. So as the function is defined in another program, another file, file2.c, this can be made available in this file only by using the keyword extern void fn. So this function, void function, will be available in file1.c only if we use the keyword extern. So this means that the function is available in some other files of this project. So it will get the value from here. But in the function, it is actually, when this is called, this will go to executing this function. In the function, it is just printing the value of I. Printf value of I is %d. So from where it gets the value of I? It will get the value of I actually from the main function, because the value of I is given in the main function, and this is declared globally, and this I is made available in the file2.c by using the keyword extern. So by using the keyword extern, I have made available the value of I, or the variable I, in the file2.c. So in that way we are getting the value of I in file2.c, that is the value equal to 9, and it is printing the value in the function and going back to the main program. So in this example you can see a function is accessed from file2.c using extern, and a variable I is accessed from file1.c using extern. a variable I is made available in file 2.c using from file 1.c using the keyword extern. Next, the static type of storage class. Static local variables will not be deleted till the end of the program, even though it is inside a block or function. So this is a major difference between an auto type of storage class and static storage class. This will not be deleted till the end of the program, even though it is inside a block or function. So the scope of an auto type of variable is increased to the whole body of the program using the static keyword, static storage class. The scope of local static variable is limited to the function or block in which it is declared, but will retain its value in multiple calls to the function till the end of the program. Scope of global static variables is limited to the file in which it is declared. The keyword is static. Memory allocated when it is declared and deleted at the end of the program. Memory is allocated when it is declared and it is deleted at the end of the program. It is deleted only at the end of the program. Lifetime is till the end of the program. It retains the value and it is available for multiple calls of the same function. So actually the scope is actually not incremented much. Next is static storage class. The static local variable will not be deleted till the end of the program, even though it is inside a block or function. The scope of local static variable is limited to the function or block similar to automatic type, but it will retain its value in multiple function calls to the function till the end of the program. So it will be available in multiple functions calls to the same function till the end of the program, but it will not be deleted similar to that of a automatic variable. The scope of global static variable is limited to the file in which it is declared. Keyword is static. The memory allocated when it is declared and deleted at the end of the program. Memory is allocated when it is declared and deleted at the end of the program execution. Lifetime is till the end of the program, that is, it retains the value and is available for multiple function calls of the same function. To show the scope and lifetime of static storage class, here a global variable num is equal to 10, int num is equal to 10 is defined as static storage class. The meaning is that the number 10 will be available within this program only. That means this cannot be accessed in another file using the extern keyword. So making it a static, making this variable as static will not make much difference in this program compared to a normal global variable, but this will not be available in another file externally. That is a difference that makes when we use a static along with global variable. So the num will be available throughout this program. Then I have defined int I is equal to 1. I is not a static type of variable. this will be available in this block only, in the main function only. I is not a static variable. And count, at this point count is declared initialized, and this count is of static type. This count is of static storage class. The meaning is, even though it exit this function, this is a function show count of int s, even though this exit this function, the variable count will remain. It will not be available external to this function, but this variable will not be deleted. The memory allocated for this variable will not be deleted. The value that is stored at last stage of this program will be stored in that counter. Okay, so we shall see the program line by line. In the main function, int I is equal to 1 and num plus plus is done. That is, num is defined as 10, so num plus plus at this line is, this value is equal to 10, and after executing this line the value will be 11. Num value will be 11. So show count 11 will call this function, show count of 1 will, I will call this function, and it is coming here. The I value is 1 and the static int count is equal to 0. Count is 0 and the s value is 1 now. So count is equal to count plus s will be equal to 0 plus the received value 1. That means the count will be equal to 1 and num plus plus, the num that is available at the end of the last step is 11. So num plus plus at this stage is 11, and after executing this it will be equal to 12. After executing this line, this will be equal to 12. So what is displayed is the value of count equal to 1 and the value of num which is equal to 12. Okay, so the last value that is inside this count is equal to 1. So this will not be deleted. If that was a normal automatic variable, this count value will be deleted, but this will not be deleted even though it exits this function. So it will come back to the main function. Then num plus plus is done. So the last value of num is 12. So num plus plus at this stage is 12. After executing this, the num value will become 13. And again calling the function show count of I. The I value is not changed. I value is not changed here. I is 1 itself. So the same value 1 will be assigned to s, the formal variable s. So now s is equal to 1 and the next line, that is the static int count is equal to 0. That line will not be executed, that is it will not be initialized again to 0 because the last value that we have is count is equal to 1. So this line will not be executed again to reinitialize the value to 0. What I said is this line will not be executed, as the last value when it exits the function was equal to 1. Now what is calculated is count plus s. Count plus equal to s means count plus s. That is 1 plus 1 will be calculated. The value is 2 now. That means the value of count is 2 now. And num plus plus, which is a global variable, the value will become, the last value is 13. So at this stage the num value is 13, and after executing num plus plus the value will become 14. So at the end we have num value is equal to 14 and count value is equal to 2. These are printed. Count value equal to 2 and num value equal to 14, and it will exit the function. So we can see the count value, the memory allocated for count was retained till the end of program. Till the end of program the value of count is retained, but it is available only within the function. Show count function. The last storage class is a register. It is used for local variables to make faster functionality. The scope of the register storage class is local. It is inside the block or function in which it is declared. Keyword is register, and the memory is allocated in the CPU register. That is a major difference compared to other storage classes. The memory will be allocated in the CPU registers when it is defined, so that the operation will be faster. The compiler may or may not store the variable in CPU registers, and that will be based upon the availability of that CPU registers. That CPU registers may be in use for some other purposes, so the compiler may or may not allocate the memory in the CPU registers. The lifetime is within the block or function in which it is declared. An example. In the example I have shown a count as register storage class, and it is counting from 20 to 49. 22 less than 50, that is 49, using this printf function. So this will not make much difference even if I use the keyword register or not, because in the program functionality there is no difference. It is both same. If I use the register or not, the functionality will be the same. But as the register storage class will assign this count inside the CPU registers, the operation will be faster. Only the change is in the speed of operation. The operation will be faster. Normally for some counting purposes we use the register storage class, where the faster operation is required. Thank you. You can ask your doubts in the comment box below.